Good morning to Doctor and my fellow friends. My name is Chan Zhi Ting. I'm from Section 7. Today I'm going to present about the individual assignment about polymer of subtopic self-healing polymers. What is self-healing polymers? Self-healing polymers are smart materials that can heal themselves after damage and restore their original set of properties. Self-healing polymers are synthetic or artificially created substance. This type of substance have built-in ability that can automatically repair damages without any human intervention. Self-healing is the capability of a material to recover from its physical damage. The spontaneous self-healing capabilities of self-healing polymers offer alternative solutions for damage repair of polymers, especially for cross-linked thermosets that are conventionally unrepairable and unprocessable. So how to construct self-healing polymers? There are both physical and chemical approach have been used to construct self-healing polymers. These include diffusion and flow, shared memory effects, heterogeneous self-healing system, covalent bond reformation and reshuffling, dynamics of supramolecular chemistry or combinations theory. This is the example of the process of cell repairing. So this is the physical approach and chemical approach and the psychochemical approaches. So let me show some video. So this is the example of polymerization reaction. So what is self-healing mechanism of self-healing polymers? Self-healing polymers can be classified into two categories based on their self-healing mechanism. First is the intrinsic self-healing and intrinsic self-healing. Autonomous self-healing polymers follow a three-step process. The first response is triggering or actuation that happens almost immediately after damage is sustained. The second response is about the transport of material to affected area. And the third response is the chemical repair process. This process differs depending on the type of healing mechanism that is in place. So for extrinsic self-healing, the healing agent body is usually embedded in the polymer matrix through microcapsules or vascular networks. During the polymer fracture, the capsules or vascular networks will break, which release the healing agents that can react with each other or interact with the matrix to heal the cracked surfaces. Extrinsic self-healing is desirable for many applications that require automatic healing of damages without manual intervention. However, due to the consumption of a healing agent, it is less effective to repair the second damage at the same location of the material. Intrinsic self-healing. This material is based on the dynamic bonding have been rapidly developed, which are repeatable without the concern of depleting the healing agent. The first design strategy of intrinsic self-healing polymers is based on the dynamic non-covalent bonding among polymer chains, such as the van der Waals interaction, hydrogen bonding, metal-ligand coordination, and ionic assembly. With the non-covalent bonds built on the chain backbone, The polymer chains could break and reconnect on the fracture interface upon stimuli, leading to the interfacial welding for damage repair. The second design strategy of intrinsic self-healing polymers is to build dynamic covalent bond on the chain backbone to enable the chain breaking and reforming. Such polymers are typically referred to as covalent adaptable networks, CANS. So this is the example of extrinsic self-healing and intrinsic self-healing. So what is the industry that involves self-healing polymers? Self-healing polymers are receiving growing interest in a wide variety of applications to promote the survivability and lifetime of polymeric products such as electronics, healthcare monitoring, and protective equipment. So, for example, the polymer nanocomposite meshes for flexible electronic devices. Polymer substrates capable of self-healing are beneficial for electronic devices to extend the service time and reduce maintenance costs. The efficient self-healing is generally realized through the formation of reversible interactions between the dynamic polymer chains of two fractured surfaces. However, on the macroscopic level, the voids in the highly porous polymer mesh prevent it from providing adequate closed interfaces for the dynamic recognition to occur. Thus, most published researches on self-healing nanofibers are still based on the concept that the self-healing agents are encapsulated in the core parts of core shell fibers. So, the development of self-healing polymers are shown above. Firstly is the cross-linked polymers. The second is the polymerization of multifunctional monomers. Tire-based polymers. Poly, also known as urea urethane. Self-healing ceramics. Carbon nanotube networks. Self-healing cementitious. Microcapsule healing. First-D, 2D, and 3D vascular-based polymeric systems. And hollow tube polymers. So this is the reference that I used to do my slide for the topic self-healing polymers. So that's all from me. Thank you.